And ta-da! Welcome back, Mindsetters. I hope you guys are ready for this Learn Extra session today for grade 10s, looking at physical science. I'm excited to be back, and I've been missing you guys so much. Oh my goodness, it's not been the same. But
Haven't you had
anyway,
a good holiday, though?
it was such a good holiday.
Good holiday.
Said goodbye to 2012. It was so much fun. But yes, we're here today, and I'm here with Tracy, who's going to be taking us through today's session. Tracy, how are you doing?
Doing well, thanks, Ty. Very
Festival's
well.
good?
Yes, always good. And
Yeah.
we're looking forward to the new year and getting stuck in with
And
grade
getting
10s.
in there and getting into pass exams. You know.
Absolutely. Going to
Right.
be a very good year.
So what are we looking at today?
We're looking at matter and materials, which is the start of the syllabus, and classification of matter. Some of the ideas you might have heard of before and in some of your junior grades, but it's fundamental physics and chemistry. So it's incredibly important for you to pay attention and make sure that all those concepts are very clear in your minds.
Yes, so seems like it's going to be a fun one. Got some experiments going on.
We've got some experiments. We're going to be looking at the classification of different things and the properties of matter and how we can classify them. So we're going to be looking at some practical things. So stay tuned and we're going to have fun.
All right, so while you make your way
Right
across
to
the board.
it.
Mindsetters, it's been a while. We've gone through the holiday. You guys started to forget things. But I want to say to you, grade 9s, who've now become grade 10s, congratulations. And I want to say, in fact, no, since you're new, they should get to the drill. The drill is basically you need to get on the page, www.facebook.com/learnextra. Chat to me, let me know what you guys are thinking. If you're lost in it, if you need help, post on the page. And also you need your 3 Ps. You need your pens, pads, and your phone so you can make sure they can chat to me and let me know what you guys are thinking, as I said earlier. And don't forget to check out our updated website. Go to www.mindset.co.za/learn/extra/live. I know it's a long one, but just do it. Then you can follow our schedules, and also there you can find notes. You can find everything that you need to keep up with the session today. So yes, make sure you go check that out. But for now, we actually have a session to do. So take it away, Tracy.
Thanks, Ty. Hi, everyone. Again, grade 10s, we're going to be focusing on classification of matter and materials, and it's a very important section, so let's get right to it. In this lesson, we will investigate different physical properties, and by physical properties, I'm speaking about things like elasticity, the strength of things, whether they conduct heat, whether they conduct electricity, all those types of physical properties. We will use these properties to classify or group matter into various different organizational groups so we can think about them some more, and then observe the differences between mixtures, compounds, and elements. And that's going to help us in terms of our definition of what a compound, what a mixture, and what an element is. Let's get straight into it. So firstly, we need to make sure that we've got very clear understanding in terms of all these definitions that you're going to be faced with in this chapter. So let's have a look at the first one. These are key concepts. I highly recommend that you jot some of these down and you make sure that they are very clear in your minds. So, physical properties of matter, melting point. Melting point is a very important one. You might say, well, I know what melting point is. It is a specific temperature. So always a temperature in degrees Celsius, or we often would use Kelvin in science, at which a substance changes from a solid to form a liquid. So maybe we're thinking of a little block of ice, and there's my little block of ice with a little puddle of water around it, and the temperature, that ice would melt would be 0 degrees Celsius, where it's going to change from being a solid state, water as a solid, ice, or going to a liquid as in liquid water. Remember, it's a temperature point at which that substance would change from a solid to a liquid. Let's go through the next one, boiling point. Again, it's a temperature at which a substance can no longer remain as a liquid state, so it would change, a little arrow for the change, to form a gas. So here you're thinking liquid water changing into gaseous phase, maybe thinking of the kettle boiling, and you can see the liquid changing into a gas. Then let's go in terms and talk in terms of a little bit about conductivity. Now, conductivity is a big word, but it really means to transfer. So conductivity is a big fancy word that means that can pass something through. So we've got different ideas in terms of conductivity. We have thermal conductivity, and this key idea of thermal is relating to temperature. Thermal conductivity would be temperature related, so you're thinking, does this substance conduct or transfer heat well? Now, some things conduct heat very well. Metal, I'm sure you've gone before on a hot summer's day and touched a metal, sat down on a metal bench, or maybe you pick up your bicycle and you're touching the metal part and it's hot. That's because metals, well, if it's a hot summer's day in the sunshine, that substance has the same temperature as the surroundings it is in, if it's been left there for a long enough time. And so, but when you touch it, that metal allows heat to flow through it very easily, and so there is significant thermal conductivity, and you might feel like your hand is burning. Or think of even a metal pot. If you were to take a metal pot, let's draw a yellow pot. Imagine this is a copper pot. And you lift that pot with the handles that are also metal, and it's been cooking on the stove, and it's been making some nice food, and you lift that pot, it's going to feel very hot because metals conduct heat very well. So thermal conductivity is the ability of a substance to conduct heat or transfer heat. I don't like using the same word conduct in conductivity again, because I want you to make sure that you know what each of those words mean distinctly. So thermal conductivity, the ability of a substance to transfer or to conduct heat. Metals are a very good example, whereas something like wood would not be a good would be a good example of of one that is not a good thermal conductor. Or sometimes you can have plastic handles on the sides of a pot that make sure that when you lift it up, you don't burn yourself. Let's keep moving. Electrical conductivity. Well, again, the ability to transfer. So what do you think it's going to be? Electrical conductivity, the ability of a substance to conduct or transfer electricity. Again, I want you to start thinking about what is a good electrical conductor. Now, for electricity to flow, charged particles need to be able to move through a substance. So either electrons, or if you've got a solution, maybe it's ions that are free to move. So start to think about what substances would allow the flow or the transfer of electrons in order to conduct electricity. Let's get through to density. Now, density is something you might have studied in the past. We're speaking with density about the ratio of the mass to the volume of a substance. And it kind of reflects back to how closely packed the substance is. So when you're speaking about density, if you've got, and I'm going to write an equation down here, density, capital D, is equal to, let's change that, equal to sign. Density is equal to the mass divided by the volume. And it's always measured, often measured in grams per cubic centimeter. The mass, we're speaking about what the amount of matter, okay? Whereas the volume is how much space it takes up. So if something is tightly packed, it has got a lot of matter in a small space, it's going to be very dense. Whereas if you've got a small amount of matter in a large space, it would not be very dense at all. And you can think in terms of density as, will this thing float or will it sink down to the bottom? Things that are denser than maybe the liquid we're putting them in, would sink to the bottom. things that will float will be less dense than the liquid we're putting them in. Magnetic properties. Magnetic properties should be quite straightforward. I'm sure you've seen a magnet or played with a magnet before. The ability of materials to be influenced by a magnetic field. So these would be certain substances that have the ability or that are either attracted or repelled by a magnetic field. And you have various magnetic fields, but any magnet will have a magnetic field around it. So you're thinking here of substances like iron, cobalt, and nickel. Now, if you look at your periodic table, those three are next to each other on the periodic table, so it makes it really easy. There are three metals, but not all metals are magnetic. The three, iron, cobalt, and nickel, next to each other on the periodic table. Now, the last one I would like to discuss is to discuss this idea of strength. Let's just give ourselves a bit more space as we work through strength. Now you can see we've got quite a lot written here, so let's tackle it one bit at a time. If you say something is strong, the strength, there are different ways to test the strength of a material. And usually we're going to apply an external force. So put something else in, apply a force to the side, and see what's going to happen. An external force is applied that to a substance. It may stretch, but then return to its original shape. Now I've got here an elastic band. This can stretch very easily and return back to its original shape when I release it. If it's able to stretch and return to its original shape, we would say that the substance is elastic. Okay? Like an elastic band. Hence the name. Substances that stretch but do not return back to their original shape are called plastic. And that's a great one. If you think of a plastic bag, you can play with a plastic bag and you can stretch the plastic bag, but it won't be able to go back to its original shape. Even if you took just a shopping packet and you stretched it, it deforms and it can be stretched, but it doesn't go back to its original shape. You can stretch some substances to form thin strands of wire. These are called ductile. Very important, and if you think of a copper wire, it's important that we can stretch it out to thin wire shapes. Some substances can be stretched to even form thin sheets. These are called malleable. Another big word, malleable, it means it can be shaped into a certain shape. And by malleable, you're thinking of all metals. Metals can be, if you think of a metal worker hitting against different things with a hammer and shaping some beautiful things out of metal, because they can be shaped and forced into various different shapes. Substances that break or shatter when a force is applied are called brittle. Now here I'm thinking of something like a salt crystal. You know those salt grinders or pepper grinders. Salt crystal though, if you apply a force to just the one surface, what's going to happen is that all those particles shift over by one or a few ions along the line and actually force each other apart, and so they are very, very brittle, and so they shatter when a force is applied to the one side. So let's go through each of those again. Elastic means something can stretch but return to its original shape. Plastic means it can stretch, but it will not return to its original shape. Ductile means it can form thin strands. Malleable means it can be formed into a shape, various shapes. And brittle means something will shatter or break when a force is applied to the one side. We've gone through quite a number of definitions, and we're going to take a break in a moment. But what I wanted to ask you to do is make sure that you've got those definitions, and when we come back, we're going to play with what these mean in a practical way. So we're going to look at some practical thoughts and ideas, and I hope you'll have a lot of fun with those practical things. Over to you, Ty.
All right, so mindsetters, you heard Tracy. Don't disappear now. make sure you stick around and get on the page. And by the way, you can also hit me up on Twitter. You know the link, learn extra, and you can make sure that you just keep chatting to me. I know you guys are new to the system because you just got into grade 10, you know, you're getting used to it, but you know what? It's really easy. Just get on the Facebook page, www.facebook.com/learn extra. Talk to me. Let me know what you guys are thinking. If you're having fun, hey, post it on the page. But for now, we're going to see you after this break. And welcome back, Mindsetters. I know you're new to the channel, but you know what? You need to make sure you get on the page, chat to me, let me know what you guys are thinking. Because I'm seeing a lot of new comments coming up, and you know what? I'm liking that a lot because that's kind of why I'm here, because I talk to you guys. So if you can't talk to me, then, you know, it just doesn't help. So again, for some of you who don't know me, my name's Ty. So make sure you just say, Ty, look, I'm stuck here. I'm not sure what's going on. Yeah, just talk to me. Just talk to me. We're here to help you. But for now, we got experiments to do. So I'm amped. I hope you guys are amped. And I'm going to hand it over to Tracy. Tracy, take it away.
Thanks, Ty. Hi, everyone. Welcome back. What we've got set up here is a circuit board with some batteries and some conducting wires. And what I've got is I'm just going to connect up here. And do you see that little light bulb glowing? Okay, it's there. Just got some loose connections there. You see that glowing? And so what we can see here is that this power source is providing an electrical current, causing an electrical current to flow through, and it's being transferred through these copper conducting wires. So first thing, copper conducting wires are able to conduct an electric current. So that's the first one. Now what we're going to do is test a few more things. Maybe this iron nail, piece of candle wax, some stocking, piece of wood, and what we're going to do is observe if these things will enable us to see some electrical conduction. So I'm going to get this candle wax. Do you see a light going? No, certainly not. Candle wax is not a good conductor of an electric current. Let's move that one away. Let's try the nail. So I'm touching it to that side. Get a connection. Yes, definitely there's an electric current that is passing through that iron nail. Even if I move it across here, there we have the connection, and it's allowing the light bulb to glow, which means the current is certainly passing through. So the iron nail, yes. What about the stocking? An interesting one. I'm sure you haven't done a stocking before. So let's see, I've just wrapped it around that side, and we're going to connect it there. Does it allow an electric current to pass through? Oh dear, dropping off. No, I don't see that light bulb glowing in the slightest. Definitely not conducting electricity. So the iron nail did, the stocking does not. What about some wood? Electric current? Definitely not. The light bulb does not glow, so it's not a good conductor of electricity. Let's go and report back to our table, because I've got a couple of these things jotted down. If you come across with me, we are testing electrical conductivity. We've got a battery with a light bulb using conducting wires. When the circuit is closed, the light bulb glows, and we are testing different materials. So let's have a look. What substances did we have? We had the copper wire, observation, the light bulb glows. Okay, and the next one we had was the iron nail. And what did you notice with the iron nail? Again, the light bulb glows. So yes, it's a good electrical conductor. And if I go a little bit further down, what were some of the other things that we said? We did wood. No. current, or better yet, our observation was no light bulb glowing. The other things that didn't work, the wood didn't work. What else? The stocking, the candle wax, the wax. There were quite a few things that didn't work. So electrical conductivity is allowing an electric current to pass through it. Let's go to the next one and let's see if we've got any more things to investigate. Well, here they're asking us to test some magnetic properties. Okay, properties that would be attracted, some substances that would be attracted to a magnetic field, or would be attracted or repelled, for that matter, influenced by a magnetic field. So I've got a magnet, and we're going to use that magnet to test which substances are attracted or repelled by that. So I've got a number of things, and we'll come and jot them down on our table in a moment. Won't you come across with me to have a look at some more? Ty, over to you while I get set up.
Okay, so I'm seeing a lot of people posting here. I just want to say what up to Oscar Mwila. My bad, dude. Like, I'm horrible. Like, if you've been on before, you know I butcher people's names constantly. Subusiso, Lesejo, Amir, I want to say thanks for you guys posting on the page. Keep on posting, and everyone else out there, keep on posting. Let us know what you guys are thinking, if you're lost and if you need help. But for now, we're going to get back to these experiments. Let's see.
Thanks, Ty. So in my right hand here, I've got a magnet, and if you can look closely, there's a compass, and I'm just moving this magnet around the compass, and you can see that dial moving quite significantly. Okay. Let's see what things are attracted by this magnet. So, what have we got? This piece of wood. Certainly no attraction there. What about this little piece of glass? No, nothing there. What about the plastic? Nothing. This ruler, nothing. Oh, that's interesting. Aren't most metals magnetic? No, they're not. Most metals are not magnetic. Only those three: iron and cobalt and nickel. They are all next to each other on the periodic table, so it's very easy to remember them. Have a look at this one. Oh, that's certainly a nice magnetic pull that we just had there. It's going to take a lot of energy to take it off. This is a piece of steel. It's actually used as a piece of welding equipment that could be melted and used. Steel is an alloy, which is actually a mixture of metals. So what they would do is they would heat up the metals, make them melt, and when they've got them to that melting point, they're liquids, they can be mixed together, and then it's got properties of both or a number of different metals that it's composed of. So they're not chemically bonded, but they're just melted and then added together. So it's an alloy is a mixture of metals when they are heated to liquid and then added together, and they have the individual properties of both. So of both or a number of the various properties. So this is some steel, which has got iron in it, and iron, we know, is certainly attracted by a magnetic field or influenced by a magnetic field. Let's go through this little piece of rubber bung, nothing there. The candle wax, nothing. This is also probably an alloy. This outer section of, it looks like a speaker to me, and it's certainly influenced by that magnetic field. So, once again, come and have a look closely at the compass. And as I move this magnet around, you should be able to see that compass needle that is deflected significantly by the changing magnetic field. Let's go and jot down some of our observations. So, back to the board. And I didn't test the iron nail, and I want to do that quickly. So let's grab the compass. Very strongly attracted, and will take a lot of energy to pull that apart. So the iron nail I'll write down first. the iron nail, and I'm just going to write yes, it was attracted. Oopsie, attracted. What else did we have? Wood. No. What else did we have? Other metals. Some metallic objects. And I think we had, it was an aluminium rod. No, certainly we're not. It's only those three that I mentioned. Steel, which is an alloy of iron with other things. So that certainly is going to be have the properties of the iron, which will be magnetic properties as well. What else did we test? The rubber bung. I'll just add them in here with the wood, the rubber. We had quite a number of them. Plastic, all of those. I'm running out of space. Let me write this somewhere else. These were not. Let's even just add the plastic or glass. All of those were not attracted by the magnetic or influenced by the magnetic field. Ty, over to you for a minute.
All right. So, mindsetters, keep on getting on the page. Jabulile, I'm seeing your post. Amir, I'm seeing your post. Michelle, I saw your post as well. We're going to make sure we get to those. Guys, keep on sending your posts. And, by the way, I always tell these to the mindsetters, make sure you tell a friend, to tell a friend, to tell their friends, to tell their friends, to make sure that to join us on the page, because right now, just trying to build a big network of mindsetters and helping to, like, educate South Africa. But on that note, on that education note, we have to get back to Tracy.
We've
Tracy,
got,
take it away.
thanks, Ty. We've got quite a bit to get through, and this is probably what you would see in your textbook. So let's have a quick look as we go through the classification of matter. Now, because we have these various properties of matter, things like electrical conductivity, things like magnetism, we want to investigate them and see if we can classify the things that we see around us, the matter, into elements, compounds, mixtures, and all those types of things. So let's have a look as we go through. Matter includes all substances, so everything that that has mass and volume, everything around us, and can exist in different states. So things that exist as solid, liquids, or gases. The diagram below shows different types of matter. So matter can be separated or classified or organized into those things that are mixtures and those things that are pure substances. Now, we'll come to the pure substances probably in a while, but let's talk a little bit about mixtures for the moment. By mixtures, I'm meaning things that have been mixed together, okay? No ratio. Imagine you're making a cake or you are cooking some supper and you've got a stew going, and you're putting in some meat and some vegetables and some water and some stock, and you've got something going. Nice, yummy supper. The mixtures would be a mixture, everything that's happening inside that pot. Now, we can further separate or classify mixtures into those that are homogeneous and those that are heterogeneous. So, homogeneous and heterogeneous. Hetero means different or other, okay? Whereas homo means the same. So when you're looking at a homogeneous mixture in front of you, you can't see the various different particles or substances that are making up that mixture. Maybe it's going to be some salt water. You can't see the salt little particles inside that water. But you do know, because you can taste the salt water, that it's salty, that it's a mixture. Whereas a heterogeneous mixture, you can see the separate particles. And that's critically important. Very, very important distinction to make. Homogeneous, the same. Heterogeneous, different mixtures. If we come across now to pure substances would include elements as well as compounds. So let's go and talk through elements and compounds. I'm going to start with compounds. Compounds would be pure substances that can't be separated chemically, but They are made up of different things and that have chemically bonded together. So I'm thinking of wonderful example, H2O, water. Okay, water is a compound made up of hydrogen and oxygen that have chemically joined together, whereas elements would be the hydrogen separately, the oxygen separately as individual elements. And we're going to need to pick up from this section when we get back from a short break. Over to you, Ty.
Okay, so mindset is make sure you don't disappear. Fair enough, go get a snack, go do whatever you have to do. If mom's saying go take out the trash, or mom's saying go do this, just go sort it out quickly, but make sure you come back and get onto the page, chat to me. I'm loving the interaction, so make sure you keep talking to me. But for now, see you after this break. And welcome back, Mindsetters. Hope you had a nice little break there. You did whatever you had to do that was going to distract you. Now you're focused, you're here, you're going to make your notes, you've got your phone out, and you're going to be chatting to me on Facebook. It's important because I can't read your mind through this TV screen. So you have to help me out so I can help you out. But for now, we have to get back to the session. So Tracy, take it away.
Thanks, Ty. Let's keep going. So we've discussed compounds as chemically bonded substances. And those would always be found in fixed ratios, so 2 hydrogens to 1 oxygen to make up water. And water is a pure substance, particularly if you're thinking pure water with no other chemicals in it. Let's go across to elements. As we said, elements would be everything on the periodic table. Okay? Cannot be broken down either physically or chemically into anything else. So let's separate those elements on the periodic table. We've got metals and metalloids and non-metals. So metals have those metallic properties that you've looked at. They're good electrical conductors. They are good thermal conductors. They react in specific ways, and you can investigate those further. Metalloids are sometimes called semi-metals, and they have properties of very interesting properties between metals and non-metals. And then non-metals would be on the right-hand side of the periodic table, as you were to look at a periodic table. And they also have distinct properties, very much non-metallic properties. So we're going to move on from here, and I'm sure as you go through your notes, you're going to spend quite a bit more time looking at those different properties of each. But I want us to jump back to this thought on homogeneous and heterogeneous mixtures. Now, once again, I said homogeneous mixtures have only consistent throughout. You can't see the individual particles that are making up this mixture. Whereas heterogeneous, you can see the different layers, or you can see the different particles within it. So I've got a couple set up for you, and I'd like us to move across. Ta, is there much action on the page?
There's so much. There's so many people chatting on the page, which is awesome. So you guys have me frantically busy. So I'm stretching out that holiday stiffness, getting my fingers ready, going. But guys, it's really awesome to have you on the page. Keep on chatting, keep on talking to me. But for now, we're going to head back to these experiments that we're doing. Take it away.
Thanks so much. So what we have here is a mixture of some soil and water, and you can very clearly see that that is a heterogeneous mixture. You can see the distinct particles, and it would be incredibly easy to separate that out. In the next beaker over here, I have got some oil and some glycerine. Now, glycerine you may not know, but it's quite clear if you look closely to see these two different layers, and they are not mixing, so that would also be a heterogeneous mixture. On this side, I've got some colored liquid. It's actually water with potassium dichromate, and it's got that clear yellow color. And then the last one I'm going to make up in front of you. This is some surgical spirits, which is an alcohol that could be used for purifying. And what I've got, let's add a little bit more. What I've got is in here some iodine. Now, iodine has got a distinct color, and I'm hoping you're going to be able to see it in a moment. Let's just open this up. Some iodine. And I'm just going to put a little bit in. See. Let's go with a couple of crystals of iodine. And as I've mixed that through, can you see the color change? That is because the iodine is inside this liquid, inside this alcohol, and it's clearly changing color, causing those surgical spirits to change color. So this would be an example when all of it is dissolved, because I don't think it's all going to dissolve at the moment. But this would be an example of a homogeneous mixture. As with this, you can't see the individual particles of the potassium dichromate. But because we want to have fun, I'm going to add the potassium dichromate and see if we can get another layer on top here. See that mixture? Do they mix? No. Well, they mix, but do you clearly see that new layer that is formed? Looks really cool. And very clearly what we're going to see as we allow this to settle is we're going to see the different layers of the potassium dichromate layer, we're going to see the glycerine layer, and we're going to see the oil layer, making 3 distinct layers, 1, 2, 3, in this beaker. Excellent. Let's head back and quickly clarify our notes. So if you'd move across to the board with me. We have some observations to make. So let's jot some of these ideas down. What did we have? Sand and water. What was it? A homogeneous or a heterogeneous mixture. We could see the different particles, so it would be a heterogeneous mixture. The next one we had was the glycerine, and we had the glycerine with oil, and again that was heterogeneous. The next one we had was the potassium dichromate, and the water, and that gave us a homogeneous mixture where we couldn't see the different particles. It looked complete throughout as a new mixture. Okay, so what we're going to do is head for a break in a few moments, and when we come back we're going to be looking at making very distinct comparisons between compounds and mixtures, and then hopefully go through a few questions based on these. So Ty, over to you.
Yes, so mindsetters, if you've been checking on the page, I've been making sure whoever posts up, if you need access to notes, let me know. I can give you the link so you guys can access the notes. But other than that, you can also just go to www.mindset.co.za/learn/extra/live, and that'll take you straight to today's shows and the notes. So make sure you go check that out. But for now, we're going to see you after this break. And welcome back, Mindsetters. Whew. It's like my hands are going to cramp. Yes, keep on chatting on the page. I'm loving the interaction, guys. Keep on posting, keep on posting. And again, I keep telling you guys to tell your friends, to tell their friends, to tell your friends, to tell their friends, to make sure that all of your friends get on the page, chat to us, and build this gigantic network where we're going to be helping each other out. Mindsetters helping mindsetters, you know. So we're going to continue with the rest of the show. Tracy, take it away.
Thanks, Ty. Let's continue with our thoughts on mixtures and compounds, and we're going to take this as a distinct comparison. So as we go through, and this is very, very important, compounds and mixtures. I just want this a little bit further up. Compounds are pure substances, which means they're made up of, sure, many elements, but they're chemically bonded together, so they make up a pure new substance, whereas mixtures are impure substances. And I'm going to start with just a simple example of water. So let's clear this away slightly. So let's write up here H2O. Then as you study these things, make sure that all your definitions relate back to what you're actually considering. And mixtures, I'm going to put here sand and water. Sand and water. Okay, so compound, pure, mixture, impure. Compound cannot be separated by physical methods. You can't try and separate the hydrogen from the oxygen just physically. But the sand and water, we could certainly can be separated by physical methods. Think about how you would do that. Well, maybe with the sand and water, we could pour it through some filter paper with a funnel and collect the water at the bottom, and the sand would be left as the residue on the filter paper. All mixtures can be separated by physically separating them, and would always relate back to those physical properties we discussed earlier. It might be melting and boiling points. It might be looking at magnetism, a number of those various properties. Compounds are always in a fixed ratio. So going back to my example of water, 2 hydrogens is to 1 oxygen. Okay, those water will always be 2 hydrogens to 1 oxygen. Oxygen always. It's a fixed ratio because of how they chemically are bonding to one another. Whereas with a mixture of sand and water, you can have any random ratio. Maybe I put 1 spoon of sand in the water and mixed it up. Maybe I put 15 spoons of sand in the water and mixed it up. It is a random ratio of those components, not a fixed ratio. So let's turn and see how you could be asked questions based on this chapter. Question 1. A table below. So often you might be given a table of data. You're not going to be expected to memorize this type of table, but you certainly would be asked to interpret what this table is telling you. The table below gives the melting point, temperature at which it changes from solid to liquid, and the boiling point of different substances. And so we have here a whole list. Water's melting point, water's boiling point, 0 degrees Celsius, 100 degrees Celsius. Nitrogen's melting point, it melts at minus 210 degrees Celsius, and it boils at minus 195.8 degrees Celsius. And so you can go through the rest. Which substances will be gases at room temperature? Now in here we've got that what room temperature is. Room temperature is 25 degrees Celsius, and they would probably give that to you on a data sheet. So let's go and look at our table and say what substances would be gases. Well, in order for something to be a gas, it must have boiled. It must have changed from a liquid into a gas. So have a look. We can ignore the melting points for the moment because we're only interested in the boiling. And so let's have a look. Well, 100 degrees Celsius, at room temperature, we're at 25 degrees Celsius. So water is going to be a no. Nitrogen, yes, it will be a gas because it, at 25 degrees Celsius, it would have boiled a long time ago. It boiled at minus 195.8. So yes, that's a gas. The next one, carbon. Carbon will boil at 4,827 degrees Celsius. So that's going to be a lot hotter to get to. No, it's not going to be a gas at room temperature. Ethanol, 78, no. Carbon dioxide. Carbon dioxide, minus 57 degrees Celsius, it would boil. So yes, that would be a gas. And mercury, no, not yet. Pentane, 36 degrees. Well, it's getting close to becoming a gas. It's certainly still a liquid though. So no, that's not going to be. And butane minus 1 degree Celsius. So yes, it would have already boiled when we get to 25 degrees Celsius. So what temperature will pentane and butane both be liquids? Now, pentane and butane are the bottom ones, and we are considering at what temperature would both be liquids. Well, we've got to look, this is our top point. It has to be below minus 1 degree Celsius, because after 1 degree Celsius, butane is going to become a gas. So you've got to consider reading this table, and I would suggest as you read a table like this, if you are feeling stuck with these positives and negatives and reading off a negative graph, negative table, what I would recommend that you do is that you draw almost like a number line, and you start with 0 in the middle. Okay, that's 0 degrees Celsius. And you work your way backwards with the negatives. The positives should be fine. You know, 25 degrees Celsius you could put in there. You could put 50 degrees Celsius there. But then you need to work backwards as well. So maybe you want to put in minus 25 degrees Celsius. And so you can work backwards, and that will help you to interpret, has this thing reached boiling point yet, as you consider a line graph or a number line of your degrees Celsius. So, unfortunately, we haven't had much time to get through more questions. There will be more questions linked on the website. So, over to you. Thanks so much for having me today. I hope it's been fun. I hope you've learned so much, and we'll chat again soon. Time.
Yes, don't worry. All of them have been saying, "Oh, Tracy, you're teaching me so well." Like everyone's been saying, there's so much clarity. Like, and one of them was like, "Oh, we're reading their teacher's mind." I was like, "Yes, from our secret control room."
I hope
connected
so.
to all the teachers in South Africa. No, I'm joking. No, we just have your guys' curriculums so we can keep track with all the stuff that you guys are going through. So whatever you're learning in class, you could learn it in here too. So we're just here to just help, just polish everything so it all makes sense. But mindsetters, I cannot stress enough. Thank you guys for joining us today. Make sure you keep on joining us because we're on every Tuesday doing physical science, and we're on from Monday to Thursday. We're going to be doing different subjects. So make sure you tune in and talk to us. Let us know what you guys are thinking. If you're lost and if you need help, we're here to help you. So don't forget www.facebook.com/learn extra. We'll see you later. Cheers.